The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I will respond as soon as I can. So we're going to go on to section 7.3. But before we do you have any questions from last night's homework? Anything you want to look at before we go on?
But I had to like do them like 2 or 3 times until I got it right.
Okay.
But
Did you eventually figure them out though?
yes, after like the 3rd try, I did get the right answer.
Okay, well, anything you want to look at?
Like the one that I had the most trouble on yesterday was question. Let's see, which one was it? I think it was question 11 or question 12 on the homework.
Do you want me to bring it up or do you want to just tell me what it is? You tell me.
It is p squared minus p minus 6. And then underneath it's 5p minus 15 times 4p squared minus 11p minus 3. And then p squared minus 3p.
So have I got that correct?
Looks like it, yes.
Okay, so p squared minus p minus 6. We're going to have what, a minus 3 and a plus 2. Okay. All right with that?
Yes.
5p minus 15, we're going to have 5 times p minus 3. P squared minus 3p, we're going to have a p times p minus 3. And then I'm going to take this one, I'm going to go to the next page and factor it out. Okay. So 4p squared minus 11p minus 3. All right. Do you want me to use grouping or trial and check?
Grouping.
Okay. A is 4. B is negative 11. C is negative 3. The product is negative 12 and the sum is negative 11. So how about negative 12 and 1? So 4p squared minus 12p plus 1p minus 3, factor by grouping. 4p, p minus 3 plus 1 times p minus 3. So p minus 3, 4p plus 1. So we're going to take that and put it back on the previous page. So p minus 3, 4p plus 1.
So with those, can you start off diagonally or does it have to be like in that section you can cross off like the p minus 3 and p minus 3, or does it matter?
Let me ask you this. Can I reduce the 2 over 6?
Yes.
Can I reduce the 12 over 4?
Yes.
Can I reduce the 2 over 4?
Yes.
Can I reduce the 12 over 6?
Yes.
I think you just answered your question. It doesn't
So it
matter.
can go, it does not matter. Okay.
Matter. Because basically, if you
So
wanted
there's no
to,
order?
you could do this. In other words, they're all being multiplied because you multiply straight across. So I could cross out those 2, or I could cross out those 2. Likewise, I could cross out those 2 or those 2. Just make sure you only use each thing once.
Okay.
All right. So I've got 2p minus 3s on top, 2p minus 3s on the bottom. Those are going to go. And that's all it's going to go, isn't it? So I've got p plus 2, 4p plus 1, and on the bottom 5p.
So we don't have to distribute the top answer, it just stays as it is in the parentheses?
Yeah, unless it tells you otherwise, I believe you can keep it factored.
Okay.
Try it and see what happens, but I think they'll accept it. All righty.
Mhm.
Any other ones you want to look at, or?
That was kind of it for mine, the one that I struggled with the most.
Okay, anybody else here got any questions from yesterday? Okay, we're going to go on then to section 7.3. We're going to look at two things today. The first thing is adding and subtracting fractions that have the same denominator. Okay, so let's start out with something like this. 9 over x plus 2 over x. When you're adding fractions with the same denominator, you add the numerators over the common denominator. Or how about, let's see, 2x over 25 minus x over 25. When subtracting two fractions with the same denominator, you subtract the numerators over the common denominator. 2x minus x is 1x over 25. Any question on those two examples? All right. Let's say I've got this situation. X over 18 plus 5 over 18. That would become x plus 5, the quantity, divided by 18. And that's as far as I can go. Let's say I've got 7/10 plus 3y over 10. That would be 3y plus 7 all over 10. If I have b cubed minus 8 over 10 b to the 4th plus 8 over 10 b to the 4th, that is b cubed minus 8 plus 8 over 10 b to the 4th, adding the numerators over the common denominator. Now, simplifying the numerator, the minus 8 and the plus 8 would cancel each other out. So now I've got b cubed over 10b to the 4th, but I can reduce b cubed over b to the 4th, and that becomes what? B to the negative 1 on top, which then becomes 1 over 10 b to the positive 1 on the bottom. Okay. Any questions about that? How I got that b to the positive 1 in the denominator? Anything there?
Nope.
All righty. Let's see here. Y plus 2 divided by 10z plus y plus 4 divided by 10z. That's going to be y plus 2 plus y plus 4 over 10z, which is 2y plus 6 over 10z. I could then factor a 2 out of the numerator and then reduce 2 over 10 to 1 over 5, leaving me with y plus 3 over 5z. Any questions there? Need to oil this chair. All right. How about this? 2 divided by r squared minus 3r minus 10 plus r divided by r squared minus 3r minus 10. That's going to equal r plus 2 over r squared minus 3r minus 10. And that's going to equal r plus 2 over r minus 5 times r plus 2, which reduces down to 1 over r minus 5. A common mistake people make is they'll take this and instead of reducing it, they'll cancel it and then they'll just say the answer is r minus 5, but it's 1 over r minus 5. So watch out for that. Okay. Let's see here. 8x minus 7 divided by x plus 3 plus 2x plus 37 divided by x plus 3, which is 8x minus 7 plus 2x plus 37 all over x plus 3, which is 10x plus 30 all over x plus 3, which is 10 times the quantity x plus 3 over x plus 3, which is 10. Still doing okay?
Yep, makes sense. You're just really
Alrighty.
fast.
What's that?
I said you're just really fast. Not
Oh.
too fast. It's just.
I can slow down. I'm in
No,
order.
you're good.
I'm not going anywhere. Okay, okay. All right. 16c over 11 minus 4c over 11 would be 16c minus 4c over 11, which would be 12c over 11. All righty. How about this one? T divided by t squared plus t minus 2 minus 1 divided by t squared plus t minus 2. So that would be t minus 1 over t squared plus t minus 2, which is going to be t minus 1 over t minus 1 times t plus 2, which reduces down to 1 over t plus 2. Ready? Let's see here. 11w plus 6 over 3w times w minus 9 minus 11w over 3w times w minus 9. So that's going to be 11w plus 6 minus 11w over 3w times w minus 9. Combining like terms in the numerator, these are going to cancel. So now I'm going to get 6 over 3w times w minus 9. In the denominator, the 3 is a factor of the entire denominator, because 3 is being multiplied by everything. That first w is also a factor of the entire denominator. But the w inside the parentheses by itself, or the minus 9 by itself, those are not factors of the entire denominator, but the quantity w minus 9 is a factor. My point being this, I could reduce these two, but I could not reduce those two. Okay, because that 3 in the denominator is a factor, but the minus 9 is not. So 6 over 3 is 2 over 1. I've got 2 over w times w minus 9. All righty. Okay, here comes the test. I'm going to give you a problem, and I'm going to predict that you're going to get it wrong. Isn't that just nice of me to say, oh, you're going to get this one wrong? Let's see what happens.
Yesterday I said you tried to trick us and you told me you don't.
Oh dear. Oh dear.
Yeah, busted.
Okay, I'll have to go back and erase the tape from yesterday. The evidence is too incriminating. All right. But I'm not going to trick you. Let's see if you trick yourselves. Okay. So work that out. I'll give you a minute here, and then we'll see what you did. Prove me wrong by getting it right, but I think you're going to miss it, and I know exactly what you're going to do wrong. How mean.
No pressure.
The pressure's on?
Yeah.
When somebody thinks they've got the right answer, let me know so I can shoot them down and tell how badly they did it. That's just awful. How dare I say that? I probably shouldn't say.
I'll be that person.
Yeah. Okay. What'd you get?
Okay, I'm pretty sure I'm wrong, but I got 2 and then times x minus 3 over 3 times x plus 5. I did it. Okay,
Sorry.
that's all right.
That's wrong. But
Did I
good
get
for
the
you.
wrong answer you thought I was gonna get though?
Well, we'll find out. Okay. But good for you for being willing to, stand in front of the firing squad there.
Yeah,
Okay.
yeah.
So let's go back for a minute. Let's take a look at that problem. Okay. I was subtracting one thing, right? So subtracting one thing. Up here, I was subtracting one thing, subtracting one thing. Here, I was subtracting one thing, so subtracting one thing. The problem here is I'm subtracting that whole group. So what I need to do is I need to write this, 5x plus 8 minus the quantity 3x minus 2. Because if you don't quantify it, you subtract the 3x, but you don't subtract the minus 2, and you end up with a minus 2, whereas in fact you should have a plus 2, as we're going to see here in a minute. Okay, so I'm going to get 5x plus 8 minus 3x minus a negative is plus 2. Did you have a minus 2 there?
Sure did.
What?
Yeah.
Sure did. Okay, yeah. So and I kind of set you up for that by not
All right.
mentioning it ahead of time, because
I was ready. I just gave it a try.
I just wanted you all to fail so I would feel better about myself.
You're welcome.
No. Okay, now, but do you understand why I had to distribute the subtraction to both terms?
Yeah, it makes sense now.
So you'll never make that mistake again.
No.
No? Okay. So 2x plus 10 over 3x plus 15. We're going to factor a 2 out of the numerator and a 3 out of the denominator, and the whole thing nicely reduces down to 2/3. So the moral of the story, watch out for those subtraction signs. They're dangerous, okay? With addition, it's not a big deal, because if we go back up here and look at, let's see, here, adding those two, I don't have to worry, because adding the quantity, you still get the quantity. I mean, technically, I could have done this, but it doesn't change anything. It's the subtraction that you've got to be careful of, okay? Let's do another one of those. Give you an opportunity to get this one correct. How about that? Let's see here. 7x plus 7 over 5y minus the quantity 2x plus 7 over 5y. All right. So this is where you get to stick it to the man. Tell me where to put it. Okay. Must have had too many Wheaties this morning. Let me know when you think you've got an answer. I'll bet you get it right this time. Nothing yet? Still working? Or are you waiting for me?
I'm waiting.
You're waiting. Oh, come on.
I
All
got an
right.
answer. I'm just like, is it right? Is it not right?
Okay. Did you get X over Y?
I did.
Yes. Victory. See there? You had your chance. All right. Because it's 7X plus Y minus the quantity 2X plus Y, right? Over 5Y. So it's 7X plus 7 minus 2X minus 7 over 5Y, which is 5X over 5Y, which is X over Y. So you got it right, okay? So remember, when you're subtracting, you've got to distribute the subtraction to the entire numerator that you're subtracting. All righty, we good to go on, or do you need to wrestle with this some more?
I'm good.
Okay, all right. Now, let's see if you remember how to find a least common denominator. All right, let's say I've got 1/4 plus 5/6. Okay. To add these two fractions, I need a common denominator, and I want to find the least common denominator. So what is the least common denominator of 4 and 6? Anybody?
Is it 12?
It's 12. Now, this one hopefully is easy to see, but let me go through the process of how you would find it if you couldn't see it. What you do is you factor each denominator down into its prime factors. So 4 is 2 times 2, and 6 is 2 times 3. The LCD, the least common denominator, is the product of the highest power of each different prime factor within all the different denominators. So I've got 2 squared here, 2 to the first power, 3 to the first power. So it's the product of the highest power of each different prime factor. So I've got 2 squared, 3 to the first power, which is what? 4 times 3 is 12. Are you okay with what I just did there?
I think so.
We'll find out.
Maybe just sing more of it will help.
Okay, all right. How about 12 and 18? Let's go 5 12ths and 7 18ths. Okay. What's the least common denominator of 12 and 18?
36.
Great. How did you get that?
I just multiplied 18 by 2, and then 12 can also go into 36.
Okay, okay, and that works unless things get really big and really ugly, which they're going to. Okay, if we take 12 and we take 18 and we do the prime factoring, we get 2 squared times 3 and 2 times 3 squared. So the least common denominator is the product of the highest power of each prime factor. Okay, do you see where I'm getting 36? And there's nothing wrong with what you did, but where we're headed, that may not work for you. This will. So are you seeing where I'm getting the 36 from?
Yes.
Okay, let's wander into the deep end just a little bit here. It says, find the least common denominator of each pair of rational expressions. So I've got 4 over 9y, comma 11 over 3y. So basically, what's the least common denominator of 9y and 3y? Okay.
Is it just 9y?
It's just 9y, because this would be 3 squared times y, and this would be 3 times y. You want the product of the highest power of each. So it's just 9y. 9y goes into itself quite nicely, and 3y also goes into 9y. Okay. So far, so good. All right, here we go. M minus 21 over 12 m to the fourth, comma, m plus 1 over 18m. So what's the least common denominator of 12m to the fourth and 18m?
$36M.
Almost 36m to the fourth power.
Why would it be to the fourth if the other one doesn't have it to the fourth?
You want the least common denominator, so you've got to take the highest power of each.
That they would both go into. Okay.
Exactly. Okay. So let's break this down again. This would be 2 times 2 times 3 times m to the fourth, 2 squared times 3 times m to the fourth, 2 times 3 times 3 times m, 2 times 3 squared times m. So 2 squared is the highest power of 2, 3 squared is the highest power of 3, m to the fourth is the highest power of m. So that's where you get your 36 m to the fourth. Okay. Next example. 27 over c cubed d, 17 over 2c squared d cubed. All right. How many 2's do you need?
One,
How many c's do you need?
3.
3,
How many d's do you need?
3.
Right.
And we're done.
Okay.
Getting better?
Yeah.
Okay. Oh, be careful. Be careful. What's the LCD?
D plus 9.
Nope. That's part of it. Okay, let me help you out here. D plus 9, factor it. What do you get? You get D plus 9, right? Because it doesn't break down any further. So it's just that whole thing, D plus 9. Then let's take the D and factor it. Well, it's just D. The problem is this D is not a factor. The whole thing is a factor. So you've got to have a D plus 9 and you've got to have a D. That's another one of those tricky spots. That's why I threw up all those warning flags. Do you see that? Yes, no?
Yes.
And again, that's a tricky thing. You got to be careful because that D, you look at it and go, well, there's a D and there's a 9. No, but this is not a D and a 9. It's a D plus 9. It's got to stay together.
Gotta stay together like its own number.
Yeah, because individually that D and that 9, they are not factors, they're terms.
Right.
So this D is not the same as that D.
Right.
No. That's a big stumbling block. Okay, so be careful. All right, now we've got b plus 1 over 5b minus 10, and then b over 6b minus 12. It says find the LCD of each pair of rational expressions. So the same directions as before, okay? Now, we're going to factor each denominator. The first denominator is 5 times the quantity b minus 2. So the 5 is a factor, the b minus 2 is a factor, but just the b or just the minus 2, those are not factors, okay? It's that whole b minus 2, all right? 6b minus 12 would be 6 times b minus 2, which would be 2 times 3 times b minus 2. So my different factors, I've got 2, 3, 5, and b minus 2, and I've got just one of each one. So my LCD is 2 times 3 times 5 times b minus 2, which is 30 times b minus 2. And what they tend to do is multiply the little stuff together like the 30, but they leave the b minus 2. If you wrote 30b minus 60, that's also correct. But anyway, you okay with this?
Yes.
All right. Let's see here. How are we doing? We've got 5m plus 6 over 4m plus 12 and 7 over 6m. So I'm going to factor the first denominator, which is 4 times m plus 3, which is 2 times m plus 3, which is 2 squared times m plus 3. 6m is 2 times 3 times m, so 2 times 3 times m, okay? So that's what I'm looking at right there. So my least common denominator, how many 2's do I need?
Is it 4?
No.
Mhm.
What's the largest power of 2's?
Oh, 2.
Okay.
Duh.
How many 3's do I need?
1.
Right. How many m's do I need?
1.
How many m plus 3's do I need?
1.
1. And again, this 3 is not a factor.
Right.
That 3 is. But you can't say, oh, this is a factor, so I don't need that. All right, so now I've got what? 2 squared is 4 times 3 is 12m times m plus 3. Okay? Good to go?
Yes.
All righty. 7 minus y squared over y squared minus 4. And then y minus 49 over y plus 2. And we're supposed to find the LCD. So I'm going to factor the first denominator. I'm going to get y plus 2 times y minus 2. The second denominator, when I factored, I just get y plus 2. So what's the LCD? Is that a factor, that y?
No.
Is that 2 a factor?
No.
Is the y plus 2 a factor?
Yes.
Okay, so what's my LCD?
Is it just y plus 2? To the third? Oh, gosh darn it.
Is my writing that bad? It might be.
No, I just missed
You can always
it.
blame me and say, oh, I couldn't read it. You're sloppy.
I should have said that next time.
You know, you wouldn't believe this, but I got an A in printing in 1st grade.
Yours isn't bad. I used to work with a lot of doctors. Yours is good.
Well, after all, Mayo Clinic, you know. But in 6th grade, cursive writing, I did not get an A. In fact, I think there's a reason they call it cursive.
I never heard that.
Well, there you go. Okay. How about, let's see. How about this one? We've got 5n squared minus 16, 2n squared plus 13n plus 20, comma, 3n squared n squared plus 8n plus 16. I'm going to factor the second one because that's the easy one. That's going to be an n and an n and a plus 4 and a plus 4, which is n plus 4 squared. Okay. We all right with that one?
Yep.
So now let's take this one and let's go to the next page to make sure we got lots of room to factor it. 2n squared plus 13n plus 20. A is 2, B is 13, C is 20, the product is 40, the sum is 13, and the numbers are 8 and 5. So 2n squared plus 8n plus 5n plus 20, factor by grouping, 2n, n plus 4 plus 5 times n plus 4, n plus 4, 2n plus 5. I know I zipped through that. So now let's take that and put it back in that previous problem. N plus 4, 2n plus 5. N plus 4, 2n plus 5. So what's my LCD? How many n plus 4s do I need?
2,
How many 2n plus 5s do I need?
1.
There you go. There's your LCD. All righty. All right. New kind of problem. It says build each rational expression into an equivalent expression with a given denominator. And this is the way it's written in the book. I want to lay it out a little bit differently that maybe will make it more clearer. I don't know. 4 over y equals what over 7y? In other words, take this and write a new fraction with that denominator. Okay? So what do I need to do to the 4 over y? What do I need to do to the y on the bottom to make it a 7y?
Multiply by 7.
So what do I need to do to the numerator as well?
Multiply by 7.
So what's the new numerator?
28.
There you go. So 4 over y equals 28 over 7y. So you're writing a new equivalent fraction with that new denominator. Okay? So instead of reducing now, we're building. We all right with that?
Yeah.
Okay. New example. 7 over y, x, y squared. So 7 over y equals what over x, y squared? So what am I missing?
Times x, y.
On the bottom, so consequently on the top. So our new numerator is 2xy. The best part about that is you get to say new numerator. Does anybody remember the commercial for new Noodle-O's? You're all too young, or maybe I've just
heard of them.
You've heard of it. Your great grandparents told you about the commercial. Yeah, or whatever. All right. You good to go on that one? I'll take that as a yes. Okay, let's see here. 7 over 6c, and we want our new denominator to be 30c squared. So 7 over 6c equals what over 30c squared? So basically, what are we missing?
5c.
So the new numerator would be 35c, and the new fraction would be 35c over 30c squared. Now, be careful, because we've been working on reducing, and you might look at that and say, well, wait, can't we reduce that? Yeah, you could right back to this, but This is about building. There's a time to build, a time to reduce. Okay, you know, Ecclesiastes. All right. Anyway, let's see here. This one. A plus 11. A squared plus 9a equals a squared a plus 9. Now things aren't quite so obvious. So let's take the original denominator and factor it. What are we missing? Give me a good Canadian answer. What are we missing? No Canadians here?
A?
Exactly, A. Because wouldn't that give me, if I put an A here, I'd have A squared times A plus 9. So my new numerator is A squared plus 11A. Or I could just write A times A plus 11. Okay, but all I needed was an A in the denominator and an A in the numerator. All right. We all right with that?
Yes.
Do you know that we live in the B nation? We live in the B nation. What do the people to the north say?
Honestly, not sure.
The Canadians, what do they say? We just talked about them.
A?
What do the people to the south of us say? Down in Mexico, what do they say?
A?
No.
No.
C. So that makes us the B nation because we're in between A and C. I know my jokes get worse and worse. Okay, that's it. I've tortured you enough for the day. So 7.3 for this evening. I'll be back at 1:15 with my office hours should you have need of me. Otherwise, have a great rest of the day. And I will stop the recording.